Good morning, everyone. In the last session, we discussed about the exception handling here. So this is the simple example we identified in the last class. If I'm not come up with this particular try and catch block here, what kind of data is printing here? Basically, the default here, our Java runtime system is going to handle an exception and is going to print the string related message. Okay, so that we already identified in the last section example class here. What the kind of message is going to throw? Like, so the arithmetic exception slash by zero and is going to provide the path of this particular exception hierarchy from where to where it is called and at what line number we got an exception. Getting the point? At what line number we got an exception is going to provide the information. So this is the simple example we identified in the last example. And later what we did, we used this particular try and catch block here to execute this particular example. So whenever we got an exception, what happens internally? It is trying to handle this particular appropriate exception class here, and it is printing this particular message. And after this, so whatever the statement we are having, the particular statements are printing. So it's nothing but whenever we are getting any exception, if I'm not using this particular try and catch block here, what happens internally? So it's going to stop the execution. Okay, the default exception handling is going to stop the execution. It will not provide wherever we are getting an exception. For example, so if you observe carefully, now what I'm doing here, I'm going to write the message. The line number 8, I'm trying to write the message. So basically, this line will not execute here. Okay, observe carefully. Whatever the line I'm trying to write to, line number 8 here. So the particular line is okay. The particular line is executing. Why the line is executing? Because at this time, we are not getting any exception. So for example, if I'm trying to remove this particular d value, so now you can see, so this line is executing message I'm getting here, and now I modified this particular d value. Again, I'm trying to run the same example. So now you can see this particular message is not printing. This particular message is not printing basically, and now we can easily understand here division by 0. So from where it is getting this message here, and inside this particular catch block, whatever the message we are having, it is printing. So now if you observe carefully, if I'm going to provide here EX, if I'm going to provide EX here, so now carefully observe the message here. What kind of the message going to print? Now you can see, so this particular, what is the name of the exception class, and slash by 0. Getting the point, slash by 0. Now what you understand here basically? Now what you understand here? And internally, each and every exception class internally is coming with a toString method. Okay. Now you can see, right now we don't have any toString here. And from where this particular toString is implemented? Getting the point. This is important. We need to understand from where this particular toString method is coming. Now if I'm going to move this particular exception and throwable, and if I'm trying to open this particular toString, so now observe carefully how this particular toString is executing. So this is the like a name of the class here. Getting the get class dot get name. So it's converting into this particular string JS, and we are trying to find out the message. So what is the message basically here? Each and every exception we are going to have different message here. Okay, for the arithmetic exception we are having slash by 0, and now you can understand here. So this particular S and is going to append with this particular message. If this particular message is not equals to null, if the message is not equals to null, what happens internally? This particular code is going to print. Otherwise, only the exception, whatever the exception name we are having, the appropriate exception is going to print. But now you can see, this is the name of this particular class name. Up to this is the name of the class name, and this is the message. So here you can see it is appending with the class name, and in between we have a colon and a message. So this is the operator. What operator we are using here? Ternary operator we are using here. Getting the point. This is very important. We need to understand how this particular ternary operator is going to work. Okay. So this is all about the simple example. Whenever we are trying to print this, whenever I'm trying to print this particular exe internally, it is calling this particular toString and it is printing the message. And the same way, in the same way, whenever I'm not adding this particular try and catch block, whenever I'm not adding this particular try and catch block, what happens internally? So the same exception hierarchy, so the same message is going to print, but internally it's going to provide the stack trace. So from where to where it is called here. Getting the pen. From where to where this particular exception is called, those information we are going to get here. Okay. So this is we need to understand. And here, so using this particular try block, what we are doing here, if I'm not handling this particular try and catch block here, what happens internally? So the default exception handler is going to provide the our runtime system here. Okay, our runtime system is going to useful for debugging our application. So if I'm not using this particular try and catch block, by using this particular stack trace, we can easily understand here from where to where this exception is called here, and at line number, at what line number we got an exception. So those information we can identify. But only the problem basically, whenever I'm trying to use this particular whenever I'm not using this particular try and catch block, this statement will not execute basically. Okay, so whenever I'm going to get an exception, line number 7, this statement will not execute. At the same way, the line number 12 also will not execute here. So now observe carefully. Whenever I'm trying to run here, now observe carefully. So whenever I'm getting an exception at the line number 7, it is not executing this. The default runtime system, what is doing it is handling the exception, but whenever it is handling the exception, after this particular exception, what are all the statements we are having? So those statements is not going to execute here. So it is going to terminate the execution here. Getting the point? So this is very important here. So instead of providing the default behavior, now what we are doing here, we are going to use this particular try and catch back. Even though the line number 7, if you get any exception, it will move on to the catch block. And finally, the line number 12, whatever the statement we are writing here, so the line number 12 statements also is going to execute it. Now you can see, so from 16 it is calling, and line number 7 we are getting an exception, and this is the toString. Getting the point. This is the toString message is printing. Okay, so just now we discussed about the toString information, how it is printing. Now, so same example, if I'm going to open, now we'll understand here how this particular example is going to print. Even whenever I'm getting an exception, the same the message we are printing here, but here after catch block. After catch block, like here this statement is printing. Why it is printing? Because we are getting an exception and we are handling an exception, and once we handle an exception, it will go to the outside of this particular catch block. If you write any statement here, so those statements will execute here. But only the problem here, after the exception, if we have any lines here, so those lines will not execute. After you are having any exception, so those lines will not execute here. Okay, so this is important here. So this kind of example will give you the more understanding about the how this particular try and catch block will work here. Okay, so we'll try to understand the one more example. So how this particular example is going to work. Let me write the one more example. So this is the something like handling an error here. Now what I'm doing here, I'm going to provide the values here. Okay, I'm trying to declare the three variable a comma b comma c, and finally now what I'm doing here. So we have a one class here, random. So using this particular random class here, now what I will do, I'm going to get the random values. Getting the point. I'm going to get random values. Now what I'm doing here, so using this particular loop here. So I'm trying to repeat around 32,000. This loop I'm making around 32,000. But internally we are going to get an exception basically. So how we are going to get an exception? Now you can see I'm using the try block here. I'm going to write the whatever the code we are going to like get an exception here. Okay. So b is equals to r dot next int. Okay. And c is equals to next int. And a is equals to something like this is the value I'm having. And using this, what I'm doing is I'm going to again I'm trying to divide the value. Getting the point. So again I'm trying to divide the value. Getting the point. So the two values I'm going to get from the random class here basically. This is the random class will give you the random value. So we cannot understand here what kind of the value we are going to get. So it will generate randomly. Okay. Now once we get any exception, what we are doing is we are going to throw an exception. And what is kind of the exception it's going to throw? Something like arithmetic exception. So the exception we already identified here. Getting the point. In the previous example, we identified this particular exception. So now what I'm doing here, division by 0, and I'm going to print the particular exception here, and I'm making a is equals to 0. So whenever we are getting an exception, I'm going to make a is equals to 0. Finally, outside of this particular catch block, I'm going to print a value. So what kind of the a value we are going to get? Because if you divide something, we'll get some value here. Getting the point. If you get like if you are trying to divide the value based on this particular exception, so if we get a positive values, if we get positive values, what happens internally? We'll get this particular a value, and the same a value I'm trying to print here. Okay. Now you can see. So this is the loop we implemented basically. Now you can see the loop is repeated multiple times. So a value we are getting minus 1, 2, 3, 4, 5, and the second iteration it is throwing an exception. For the third iteration we are getting a value 0. Getting the point. Now observe carefully what happens internally. This loop is repeated multiple times because what is the condition we are making? Around 32,000 the condition I'm given here. So these many times the particular loop is going to repeat. And while repeating the each time here, what happened internally? It's time to load the B and C value. From where it is trying to load? From this particular random class. Getting the point? From this particular random class. Now what happens internally? Based on this particular values, based on this particular B and C value, we are trying to divide something. Okay. So whenever dividing something, if we are getting 0 or minus value, what happens internally? We'll get an exception. Because so this is the division operation we are using, we'll get an exception. So this exception is handling like this here, and once it is handling, now you can see it is printing a value 0. Whenever we are getting an exception, it is printing the a value as a 0. Okay. So if the exception, if you are not getting any exception, the a value we are going to get like this. Okay. So now you can see something. These are all the values. Here we did not get any exception. But even though if you get any exception, the a value is printing. A value is printing. A value 0 is printing. Okay. Why is the a value 0? Because here we are setting a value as a 0. Here we are setting a value as a 0. Every time this loop will repeat. Every time this loop is repeated, now you can see, so multiple times we are getting an exception. The exception is handling, and whatever the loop we divide like we provided here, the loop is not stopping here. Even though we are getting an exception, the loop is not stopping here. So once you get an exception, it's moving into the catch block, it's handling an exception, again it's trying to repeat the value. So to understand a simple example, what I will do, again I'm going to put a breakpoint here. Here, the line number 12, I'm putting a breakpoint here, and I'm going to run the same example one more time. So we'll see what is the B value. So now you can see, this is the bigger value we are getting. This is the bigger value we are getting for this particular B, and same way, so C you can see, minus value we are getting. And now what we can understand here, so this is the division operation. The division operation, what happens internally, we are getting 0. The division operation is returning 0, and 1, 2, 3, 4, 5 division by 0. So now we'll get an exception. So once we get an exception, now you can see we are trying to catching an exception, and we are printing an exception. A value 0 I'm making, and A value the 0 is printing, and now you can see it's moving into the loop. Getting the one again, it's going to this particular loop here. Now, so this is the second iteration. Now you can see B value, this is the positive value we are getting, and now we'll understand C value. So the C value you can see, C also positive value. Now we will not get any exception. So again we are getting. So maybe whenever we are dividing this, maybe we are getting an exception here. Okay. So now you can see division by 0, again it is printing 0. Now we'll understand here. So third time it is printing an exception. Now you can see, now it is not getting any, getting any exception. So what we need to understand basically, so what is the division B and C, what is the value we are getting here? -1. So this particular -1, what we are doing here, we are trying to divide something. So now you can see -1, 2, 3, 4, 5. So this is the A value we are going to get. Now observe carefully, -1, 2, 3, 4, 5. Okay. So only whenever we are having 0, so when we are trying to divide with 0, then we are getting an exception. And other than this particular 0, either it is a minus value or positive value, we are not getting any exceptions here. Okay, observe carefully. So this is the way this particular loop is repeating multiple times here, and it is printing the value. Now you can see most of the time it is throwing an exception, and the exception is handling inside our catch block. Okay, so this is very important, we need to understand here. But if I'm not coming with this particular try and catch block, basically what happens internally, so the default catch block will handle, and the default try and catch block will handle basically, and it will not repeat these many times. So whenever we get any exception, so it will terminate the current example. Okay, it will not repeat this particular loop at the time of, if it get only first time, at first time if you get an exception like this, it will not repeat the loop here. It will not repeat the loop. So for example, here I'm trying to handling all the information. So observe carefully the same example I'm running. Now you can see. So whenever we get any exception, so we are unable to see this particular message here, the A value. Getting the point. So again I'm trying to run one more time. Now you can see, so it's printed 2 times here. So the third iteration here, we got an exception, but whenever we are getting an exception, so it is not providing the A values here. It is not providing this particular A value. So again, I'm going to run. because it is a random value it will generate. Now you can see right now. So so initially first time only we got an exception. Second time two iterations are completed, and third time so four iterations are completed here. At the time of fifth iteration we got an exception. Okay. So now observe carefully what we need to understand here. This is the behavior of this particular default here, and using this particular try catch block here, even if we get an exception, happily we are able to repeat the loop here. Okay. So any questions regarding this example, the random class what we are using here? Okay. Now here, what we need to understand here, basically the toString method we already identified in the object class. But now if you see carefully here, the one more toString we are able to see here. Getting the point. So one more toString we are able to see. This is not the object related class, and this is the throwable class here. What happens internally? So as I explained in the last session, the throwable is our super class for all the exception classes. Now, if we get any exception, this particular toString is going to call here, not the object class here. Basically, so from the object class, we are overriding this toString method inside this particular throwable class here. Okay. So once we override here, the override method, it will take highest priority. Getting the point. So this example we already discussed in the previous classes here. So whatever the method we are trying to override here, the toString method, the object like the override toString method is going to take highest priority here. Getting the point. This is important. We need to understand here. Okay. Now let's move on to the multiple catch blocks here. So how we can write the multiple catch blocks? So first time we are trying to define only one catch block here. But this is the way if we get multiple exception. So those exceptions are the different exception. What happens internally? Okay. So we should write the multiple catch blocks here. How I'm going to write the multiple catch blocks? So now we can understand the simple example here. The simple example basically I'm going to provide the argument values basically. So understand here, we'll move on to the one more example. So this particular example will handle the multiple catch blocks. Okay, now observe carefully. I'm trying to come up with this particular example here. So how we can use the multiple catch blocks here. The first one will use a array index out of bound exception, and later I'm going to use a arithmetic exception. Int a is equals to something like, if the length I'm going to have as a 2. 42 by year. Getting the point. So observe carefully. Now what I'm doing here? Here I'm trying to again divide the value. Okay. So now what you need to understand here? Int c is equals to, like it is the array type I'm using here. And now what I'm doing here? I'm going to provide only one value. And here, now what I'm doing here? Something like in the 99 location, like in the 99 index in the 99 index location, I'm trying to give 46 value. Okay. So now observe carefully the first catch block I'm trying to use. Okay, I missed to write the try block here. So this is the catch block I'm trying to write. Okay, and this will contain the division by 0, and finally the EX, whatever the EX I'm going to print, I'm printing. And one more catch block I'm trying to write. So this is the array index out of bound exception. Okay, and simply the whatever the EX we are going to get, the EX I'm trying to print. And after this particular catch block, I'm trying to write the after try and catch block here. Okay, so this is I want to print here. So now observe carefully. Basically, what I'm doing here, based on this particular into value. Based on this particular into value, what happens internally? If I'm giving as a 0, whenever I'm giving as a 0, the arithmetic exception will get an exception. So why we are explaining this? Why like how we are going to get the arithmetic exception? Because here what we are doing is we are trying to divide something. Okay, so right now I'm not giving any value. So a value I'm giving as a 2. So this will not give any exception. But the exception will occur at the line number 11. So is it correct or wrong? So just to think about the line number 11. The line number 11 is going to throw an exception or not. So if it is going to throw, why we are going to get an exception here? Any idea? Can you think and let me know? So at the line number 11, really we are going to get an exception or not?
Yes, sir, we will get, because we have only one number of array, size is 1. Now we are placing in the 99th element, so it will give array out of bound.
Yes, the size is out of range here. So whatever the size we created as a 1, but we are trying to insert the value in the 99 index location. Okay, so because of that, it's going to throw an exception here. Now you can see whenever it's going to throw an exception. So this is the index 99 of the particular length. Whatever length we are having right now, this is a 1. But what we are doing here, we are trying to store in the 99 location. Okay, and later the whatever the after try and the catch block we are having, the after try catch block it is trying to executing here. Okay, but right now what I'm doing here, I'm going to make as a 0. So at the time of this 0, what happens internally? So this particular arithmetic exception is getting, and earlier it is getting an array index out of bound exception, and right now it is getting an arithmetic exception. So now what you understand here? So this is a way of writing the multiple catch blocks here. So if you get multiple exceptions here, we can write the multiple catch blocks. And here, so here, this is the hierarchy is very important. We need to understand here. The hierarchy basically, if I'm going to write like this, and instead of writing this particular multiple catch blocks here, now what is another way of writing here? I'm going to comment out this all the exceptions here, and here, okay, so observe carefully. I'm going to print this message. Okay, so instead of writing these two catch blocks, basically arithmetic exception, array index out of bound exception basically is going to extend from this particular exception class. Getting the point? This is important. We need to understand. These two classes are going to extend from the particular what is the name of the class called exception. Now you can see. So it's returning arithmetic exception slash by 0 after try catch block. And if I'm going to make as a 10 here, whenever I'm trying to make a value as a 10, now it will move on to the So now you can see array index out-of-bound exception, and after whatever the try statement we defined here, the println statement is printing here. Okay. Now what you understand here? So instead of writing this particular multiple catches, so this is the another way of writing directly. You can handle an exception. Getting the point. So basically, what happens internally? So compiler or like runtime system, it needs to identify here which kind of exception we are getting here. So this is it's going to take some time here because yesterday, like in the previous classes, we already identified here the exception class. Whatever the exception class we are writing here, this exception class is extended with multiple classes here. Is extended with the multiple classes. So each and every class it's need to identify what kind of the class it is and what is the exception we are getting right now. Getting the point. So this is the some like it's like some problematic. It's going to take some time to identify what is an exception it is. Instead of writing like this, so we can try to come up with the specific class. But if you are trying to write the specific class, the hierarchy is important here. The hierarchy is important here. Now you can see so how this particular hierarchy is going to look like. Okay, so if I'm going to write like this here, what happens internally? So now you can see I'm getting a multiple errors here. So why I'm getting the multiple errors basically? Earlier we did not get any error, but right now we are getting an errors here. Because here, so what we are doing, the hierarchy is important here. First we need to give the high priority to subclasses here. First, we need to give the subclasses priority here, and later we need to give the superclass priority here. But right now, what we are doing is, so this is the superclass we are giving the priority because that it's giving me an error. So let's observe carefully. I'm going to handle this like this. So now you can see any error we are getting it. No, we are not getting any error. So why we are not getting any error? Because so this is the superclass basically, and these are all the subclasses. First we need to give the priority to the subclass, and later we can go for the superclass. And now what happens internally if other than these particular two exceptions, whatever we are handling these particular two exceptions here, if the two exceptions so if we are getting the different exception other than this particular two, this catch block will handle. This catch block will handle here. Okay. So this is the hierarchy we need to handle the exception. Now you can see the arithmetic exception we are getting here, and finally, so we are getting the same messages here. Getting the point. This is one of the important example we are discussing multiple catch blocks here. Okay. So any questions here?
Sir, I have one question. Is there any reason that we are explicitly defining the particular kind of exception? Because the superclass exception EX, that statement, it will, as it is serving all the purpose, why we are writing explicitly, sir? I would like to know.
So just now I provided the information. Basically, at runtime system, what happens if we get any exception? The appropriate exception object is going to create it. For example, here, if I'm getting that this particular exception, like whenever we are trying to divide something, if we getting this particular division by operator exception, okay, the runtime system, what happens internally, it will create an object of arithmetic exception class, not the exception object here. Okay, whenever the arithmetic object is created, what happens internally? So it needs to handle the arithmetic exception catch block. But what we are doing here, we are going to provide the superclass behavior. When we are providing the superclass behavior, it will try to check the each and every class here.
Okay.
Getting the point. So we have a multiple classes here. It's going to check the each and every class, which class object is created, and then it will realize the appropriate class object. Finally, it will print the message. So instead of checking these many classes, if you try to provide the appropriate exception, so directly the catch block will handle and it will provide the whatever the logic we are going to write inside this particular catch block.
Okay.
Okay. And
It will
one
help.
more. One second. So one more here, if you are trying to define the custom catch blocks, like a custom exception. So the custom exceptions, either we are going to define from the run, most of the time we are going to define from the runtime system, runtime exception classes. Okay, and some cases we are going to extend from the exception classes. So whenever you are trying to extending from the runtime exception class here, so the exception will not handle the custom exceptions here. Okay, so these are all the two purposes. We can go for the specific exception class and we can handle the whenever we are getting any exception. So if it is not within the range, because we provided these two exception classes here. So if whatever the exception we are going to get, if it is not in range here, we can provide the custom exception like the superclass exception class here. So this superclass exception is going to handle the whatever the exception we are going to get if the two catchy blocks are not satisfied here.
So it will help to reduce the processing time if we specify explicit exception details, right, sir?
Yes.
If we don't specify, then it will take more processing time to check all the classes. Okay,
Yes, we
got it.
need to check the type of objects here. So which type of object is created.
Yeah, sure, sir. Thank you.
Okay. So any other questions?
So one tribe, there is no idiom like for every tribe block there will be one catch block. It's not like that, right, sir?
So
For
it's
one
mandatory.
tribe
We
block,
should
it can have more, at least one catch block, but can be more.
yes.
Yeah, got it.
Okay, so now we'll move on to the nested try statements here. So right now we identify one try block and we come up with a multiple catch block. So now what we will do, so inside this particular try block, I'm going to write one more try block. So this particular section we'll call it as a nested try block here. Okay, so we'll see how this particular nested try statements is going to execute here. So observe carefully. Now I'm going to write this particular one more class here to understand this particular nested try statements here. So nested try statement I'm trying to write as our class name, and I define the main method, and internally what I'm doing basically. So here again I'm going to write the same values here. So int a is equals to something like 1 if I'm going to provide. So what happens internally? Okay, into b is equals to the same value 42 divided by a. Okay, so this is the division of exception we are going to get when we are trying to provide the zero value, and right now I'm not providing any zero value. So and this statement should come under this particular try block here. And internally what I'm doing is I'm going to write one more try block here, and here I'm trying to check the values here. If here a equals to 1, now what I'm doing is again here I'm going to provide the division operation here. So you can see a is equals to a by, here I'm trying to write a minus a. Okay, so this is the condition I'm making, and this particular condition again it's going to throw in our division operation exception, and if this particular a value equals to 2, cutting the pen, if a value equals to 2, now what I'm doing basically here, whatever the index out of bound exception we identified, the particular example I'm trying to write here. And now what we can do, (42 is equals to 99). Okay, so this is the second condition I'm making. But here, if you observe, So inside the try block, I'm going to write one more try block here. Okay, so this is, we'll call it as a nested try block here. Now, what I'm doing here. So after this particular if block is completed, so this is the catch block I'm going to write here. And here, array index out of bound exception. And simply, I'm going to provide this particular EX here. Okay, so this is the nested catch block. This is not the outer catch block. So if you observe, so this is the closing for this particular try block here, and this is the nested try block. Now what I'm doing here, so this is the nested catch block I'm trying to write here. Now finally, I'm moving into outside of this particular where we define this catch block here. I'm going to write one more catch block here, and here I'm trying to write the arithmetic exception. Okay, now let me format this code here. Okay, I'm getting an error here. Okay, so observe carefully what I'm doing here. Now I'm trying to come up with a value as a 1, and here I'm trying to divide the value. So in case if you get the line number 8, getting the point, in case if you get the line number 8 exception, what happens internally, because we are already inside this particular try block here, we are going to get an exception this. So this exception is going to handle this. This exception is going to handle here. Okay, now what we need to understand here, whenever I'm getting the line number 8, this particular arithmetic exception is going to handle. But problem here, whenever this line, if you get any exception, line number 11, now what happens internally? Because here we are not handling any arithmetic exception here. Getting the point? So if you observe carefully, what kind of the exception we are going to get? So we are getting arithmetic exception. But from where this particular catch block is handled here. Okay. So this is important here. Now we are understanding here the line number 11 will get an exception here. Okay. So to understand more here, now what I will do, I will put a breakpoint here, and I will run the same example in the debug mode, so that we'll understand more how example this nested try is going to look like, A value and B value. So here now we understand here the line number 8 is not throwing any exception. Okay. Now we are moving into the nested try. So A value equals to 1. It is satisfying here, and so we are doing the minus operations here. The minus, it's become 0. So here, based on this particular A value, we are trying to divide. So whenever we are dividing here, we'll get an exception, and the exception, now observe carefully. Which catch block is handling? Here? Okay. Outside nested try and catch block. So this is basically outer catch block. This is not the nested one. Getting the point? So this is the one advantage we are going to get basically. Whenever we are trying to use this particular nested try and catch block, if the nested catch block is not available inside this particular nested scenario, so it will try to look up the outer catch blocks as well. Getting the point? If it's going to look up the outer catch block. Inside the outer catch block also, if the appropriate exception is not available, so it will go to our default runtime system. It's going to handle an exception here. But now you can see, so basically this is the outer catch block we are defining, so to handle this particular arithmetic exception. But inside the nested try block, inside this particular nested try block only, we are getting an exception. So we don't have the appropriate catch block here, but even though if it is not available, it is looking the outside of the particular nested try and catch block here. Okay, so this is we need to understand. And whenever I'm making as a 2 here, whenever I'm going to make A value as a 2, now observe carefully. So it will try to handle the nested catch block because we are trying to, we have the nested catch block here. So this is the way we are throwing an exception. The exception is going to handle here and it is printing an exception. Okay, because we already know why we are getting the this particular arithmetic like array index bound of exception and arithmetic exception. Okay, so this is the way of writing the nested try and catch blocks here. So any questions regarding this particular nested try and catch block here?
Sir, is that last end of the catch block is kind of a final kind of
No,
exception,
it is
sir?
not a final. Basically, so this is the try block we define. For this particular try block, we define the one catch block here, and this is the outer try block here up to this. So this is the
Oh,
catch block.
okay.
So
So
each
if
try is
any
containing
of if any one of the things is not working, then it will go to the end of the catch block, right?
not end of the catch block. Basically, what happens internally?
Outer.
So here we are getting an arithmetic exception. First, it will give you the priority inside this particular nested catch block. But right now we
Okay.
don't have. So for example, here if I'm going to come as a exception.
But it will not accept the hierarchy, right, sir?
So now you can see. So it's throwing an error.
If
Getting the
it is
point.
the hierarchy, right, sir?
See. So this try block and catch block, this is different. Okay. So because this is the different try and catch block. So it is not going to depend with the outer try and so here outer try and catch block basically. So if you see carefully, so this is separate and this is separate. So there is no relation here. But when we are going to get the relation, if any exception is throwing here inside the nested try block here, if the appropriate catch block is not available, it will look up the outer catch block. Okay. But right now, what I'm doing basically is, here I'm trying to handling the subclass and a superclass. So if I'm going to run the same example in the debug mode, okay, sorry, we should change the value. Now I'm trying to change the value as a 1. Okay, now you can see what happening internally. So which exception is handling here? The nested superclass exception. It is not coming to this particular catch block. Earlier, this catch block is executed. But right now, this catch block is not executing here. Okay, so this is important here. Because
Sir,
internally only it's handling this particular catch block and it is printing the message.
sir, one more doubt, sir. Does it not follow the hierarchy if it is in inner or outer, sir? Inner to outer? That
See, basically,
exception.
yeah, it will follow. But here we are providing the catch block. So whenever you are providing the super class here, it will not go to the outer here. Because any exception, this exception class will handle here.
Okay.
Because of this particular super class, so this exception will handle here. So if it is not there, it is trying to move on to the outer class. So if I'm going to write this exception, so here, first it will go to this particular nested. If the nested is not satisfied the appropriate catch block, and it will come back to this particular subclass here. Even if this particular subclass is not satisfied, it will identify the superclass exception here. Okay, so this is the way of how handling this particular catch blocks here.
Sir, can you please write this exception EX in the place of index out of bound exception, and can you move that to the next line, sir, so that we will see the hierarchy will work there?
No, so this we already identified now. You cannot write the catch block like this. So because
Okay.
the priority is a superclass we given, again it will not go to the subclass here. First
Okay.
we need to
Okay.
give the subclasses, later we need to give the superclass priority.
Okay, sir. Got it. Thank you.
Okay, so any questions? Anyone have any question? Now, so we'll move on to the throw keyword. So how we can discuss about the particular throw keyword here. So this is we discuss about the right now try and catch block we discuss here. So basically, one example I want to provide on the finally. Okay, we'll see the later how this particular finally block is going to discuss here. And now it's the time of discussing about the throw keyword. So basically, now what we are doing here, this exception is internally created by the our runtime system, and it's going to throw the exception. Those exception we are handling here. Getting the point? This exception, like line number 11 or line number 14, if we get any exception, who is creating the objects here? Who is creating an object for this particular specific exception classes here? Runtime system is creating an object, and the runtime system only it's going to throw an exception. Whatever the exceptions are thrown by the runtime system, those exceptions we are handling here. Okay, we are not throwing any exception. Okay, so if we want to throw an exception, what is the best way of writing the code here? So using this particular throw keyword, we can throw an exception and we can create an exception. Okay, so now observe the simple example we need to understand how this particular the throw keyword is going to work basically. The throw keyword basically it is used to create an exception, and once exception is created, automatically it is going to throw an exception here. Okay, let's have a simple example. Okay, this is the throw demo I'm trying to define here, and inside this particular throw demo, now what I'm doing here, and I'm going to come up with a try block. Inside this particular try block here, I'm throwing an exception. Along with this particular exception, now sorry, you can write the message. Okay, so you can write the message like this here, and now what I'm doing here, so here only I'm going to handle an exception. Here only I'm going to handle an exception basically. So because here we are doing the two operations. So what are the two operations we are using? Okay, so what are the two operations we are doing here? So using this particular throw keyword, what we are doing is we are trying to create an object. So this is nothing but we are creating an object. What kind of the object we are creating? It is a one exception object we are creating. Okay, it is nothing but null pointer exception. We have a one class inside of a Java language, and the class object I'm creating. So whenever I'm trying to create this particular object internally, what happens internally? We are throwing an object. So here we are creating an object, and whatever the object we created here, the same object here we are trying to throw here. Okay, now you can see who is going to handle the catch block here. So this particular catch block is handling. We are doing the two operations here. But earlier, whatever the example we discussed here, so at the time of this particular line number 11, so here also the exception objects are created. So first time the arithmetic exception is created, and second time the array index out of bound exception is created. But who's created this? Our runtime system is created. But here, what we are doing is we are only creating an object here, and we are throwing in the particular object here. But how we are creating an object here? So using this particular throw new null pointer exception object we are creating, and so this is the catch block is going to handle this particular exception. And once it is handled here, now what I am doing here? Once it is handled here, basically I am trying to rethrow the exception. Getting the point? Here, the line number 10, I'm going to rethrow the exception. So now you can see, so this is basically, we are handling the catch block, and this is basically is handled by the default system. Why we are getting the second message here? Because here what we are doing is, inside this particular catch block, inside this particular catch block, again we are trying to rethrow an exception. Again, we are trying to rethrow an exception. So this is the initial way of creating an object of this particular exception class, and internally it will throw an exception. It will throw an exception. So once we throw it exception, the catch block is handled, and from the catch block, basically, just for understanding how the default system is going to handle the exception, so that we are going to rethrow from the line number 10 exception. Okay, so this is very important, we need to understand. So basically the throw keyword here, what is doing it? So if I want to throw an exception explicitly, so using this particular throw keyword, we can throw an exception explicitly. But initially what we are doing is, we are trying to create an object here. So initially, first we need to create an object, and later we can throw multiple times here. Okay, so this is important, we need to understand here. So any questions regarding this particular throw keyword?
Sir, first throw is for creating an exception object. Second throw is for rethrowing whatever the exception we got the exception. Is it sir?
See, basically it will do the two operations. It is creating an object, and internally it will throw an exception. Okay, second time this object is already created. So null pointer exception is already created. This is available inside this particular EX here. Okay, the same EX I'm trying to rethrow.
Can you repeat the last statement, sir? What you are doing in the you are
This EX will contain the object of this particular null pointer exception. Okay, basically it is a reference variable. It's a type of null pointer exception. Now what I'm doing here basically, so this reference contains the null pointer object information. Where we are creating it, so at the line number 7 we are creating an object. Okay, it is a simple example. For example, so I'm having the one test method. Okay, so it is expecting box as an object parameter. So this is the type of the particular class, and this is the reference variable. How we are going to pass basically here, whenever we are creating a box object. So if I'm going to create something like box b1 is equals to new box here. Okay, and b1 dot, we have a test method, and here I'm passing the b1. Getting the point? Here I'm passing b1. What is the b1 here? Basically it is a box object. So here what we are doing is, using new operator we are creating this particular box here. So the same variable we are passing, and internally here also it's doing the same thing. Here we are creating the null pointer exception here. Whenever we are creating this particular null pointer exception, what happens internally? This throw keyword, this particular throw keyword, it's going to throw a null pointer exception. For example, so null pointer, now I'm trying to write npe n1 is equals to new NP. NP is nothing but null pointer exception. Okay, so this particular null pointer exception object I'm creating. So using this particular throw, we can throw this n1. We can throw n1 here. Getting the point? N1 is a what type here? It is a null pointer type here. Whenever we are throwing this particular n1, what happening internally? The catch block is going to handle this particular n1. So how we are passing like this? How we are passing this particular b1? So this n1 is going to pass to the parameter of the catch block. So here we are defining like this. So this is the type of object, and this is the reference variable. So same way here, the null pointer is exception is a type here. Okay, the null pointer exception is a type, and this is the reference variable. Whenever the throw is throwing an exception, the catch block will handle, and the EX contains here null pointer object information. Okay, again the null pointer object information we are throwing here. So internally at the line number 7 also it's going to use the same, but instead of this particular EX here, it's going to use whatever the reference we are going to get for this particular null pointer exception. New NP is nothing but we are creating a new object of this particular null pointer exception class, and it contains some references here because this is also it's creating under the heap memory only. The object is going to create under the heap memory here. It's contains the reference variable. The reference only it's going to throw here, and whenever it is throwing here, so it's identify the catch block. Now you can see catch block basically it is a parameter. Catch block basically it is expecting catch block basically it is expecting the parameter. What is the parameter type? It is a null pointer exception type here. Okay, it's like you can think about the method. So how we pass the object as a parameter in the previous example. So same way here, the catch block is also expecting the parameter of null pointer exception, and we are passing. So is going to pass here. The runtime system is going to, when we are throwing an exception, automatically the runtime system is going to identify so whether the catch block is going to contain the null pointer exception related information or not. If it is contained, handle it will the line number 9 and line number 10 here.
Sir, line number 10, whatever the exception it is having in the reference variable, it will print in the console. Is it, sir? That throw ex statement.
So right now what happens internally, so line number 9 we are printing, and line number 10 again we are trying to throw the same exception. So whenever we are trying to throw the same exception, what happens internally, so it will look the same catch block. From the catch block, if you are trying to throw, what happens internally? The default runtime system. Like yesterday we discussed about if I'm not handling the try catch block, what happening internally? The default runtime system is going to handle an exception, and it will provide the default message for this particular class here. Getting the point. So same way here also, because already we are handling the catch block. We are providing something the custom message here. Like and internally we are rethrowing an exception. Whenever we are trying to rethrow an exception, so it's going to handle by the default system because we don't have a catch block. So the another way of writing this. So if you understand the simple example, so what can I provide? Let me write the same example with a different way. So demo npg. Okay, so this is the method I'm trying to declare here, and I'm going to create the method, and internally, so if you observe carefully what I'm doing here, I'm going to print this, or if I'm going to throw this particular exception here. Now you can see from this particular demo np. Okay, from demo np, what I'm doing here, I'm creating a null pointer exception object, and the null pointer exception internally it's going to throw this particular catch block is handling. From the catch block, we are trying to throw the same exception. So whenever I'm trying to throw the same exception here, I'm going to use the catch block here. Now you can see null pointer exception here. The null pointer exception basically here I'm going to handle here. EX. Now see the differences, the earlier example and the current example. Earlier example and current example. So earlier, so it's got some default handler, but right now we are not getting any default handler here. So why we are not getting the default handler? If you observe carefully, so first what happens here, the main method will call here, and the try statement is going to execute. From the try statement here, we are calling the method we are calling here. So whenever we are calling the method, internally we are using the again try. So we are trying to throw the exception. This catch block will handle. First, it's going to provide the highest priority, this particular catch block here. Okay, so from this particular catch block here, we are trying to handle the exception here. So let me write the message here. So to understand from okay, from this particular demo np method, and this will I write here. Okay, now if I'm going to print the same one, so see the messages here. First one is calling from the demo NP method, and the second one is calling from the main method. Getting the point? So now, so the main method is executed, the try block is going to execute, and internally we are calling the this particular NP method, and internally we are creating a null pointer object. So once we create a null pointer object, because of this particular throw keyword, it's going to throw an exception. So once this particular exception is going to throw, highest priority is going to move on to this particular catch block, because so this try is closed here and the catch block is available here. It will not go to this particular main method. Okay, it will not go to this particular main method catch block, because the try block is contain the catch block. This catch is going to execute. So while executing it, basically what we are doing here, again we are trying to rethrow the exception. Whenever rethrowing an exception, now it will come back to the this particular catch block here. Now it will come back to the this particular catch block. Why it will come back to this particular catch block? Because so here the nearest catch block. So the nearest catch block this is. If this particular catch block is not available, now it will go to the default handler catch block here. Okay, so this is very important here. Whenever we are going to write any the try and catch block here, if the appropriate exception is not matching, it will look up the hierarchy from what is the nearest catch block. So wherever we are trying to handle the catch block, it will go to the nearest catch block. For example, this method is called from the around 4 classes. Okay, first class, second and third and 4 classes. Inside the fourth class, we have the demo NP method. Okay, now what happens internally? From demo NP method, if you are trying to throw an exception, it will go to the third class. Inside the third class, if we have any the null pointer related catch block, it will execute here. So if it is not there, it will look up the second class. Inside the second class, same way. If you are having any null pointer related information catch block, it will execute. Otherwise, it will go to the first class. So inside the first class also, if it is not there, now it will go to the default runtime system. It will go into execute and it will stop here. But in case any one of the class we are going to have the appropriate catch block, so the whatever the request we are trying to provide, the request is not going to terminate it. Once the catch block is completed, after the catch block, if you are trying to write any statements, those statements are going to execute it here. Okay, so this is important because already this section we implemented after the try catch block, the message, the printer message we already provided here. Okay, the way of executing the catch block here. So because of that only, this particular catch block is taking the highest priority. If this particular catch block is not available, what happens internally? It will go to our runtime system, because this particular class is not going to extend it to any other classes here. Okay, so this is, we need to understand about the hierarchy of catch block execution here. Okay, so any questions?
No questions from my end, sir. Thank you. I got it.
Okay, so if you don't have anything, so I'm going to stop the session here. So tomorrow we'll discuss about the throws keyword. So right now we are discussing about the throw keyword. So once a throws keyword is completed, we'll move on to the finalize here. And after finalize keyword, we'll try to move on to the custom exception. First, we'll see what are all the built-in exception classes we are having. Once we are familiar with the built-in exception, we'll go for the how we can come up with our own exception classes. So what are all the different way of writing our own exception classes? Because the custom exceptions, it's going to give you the more information in the real-time application. Not only this particular default, what are all the exception we are having, we are going to create a multiple custom exception classes. Okay, so those information we
Yes,
are
sir.
going to discuss in our tomorrow session.
Sir, I have one question.
Yes, tell me.
Yes, so I just joined today's session because Sai sir just sent me added me in a group, so I joined it. But what about the rest of the sessions that I missed from session 1 to 12?
Okay, just message me in the WhatsApp. I will provide.
Okay. Oh, I don't have your WhatsApp number.
So wherever you got the message, you can message there only.
Okay. What's your name, sir?
Uh, so I think it's Java technology. You are going to have the name. So just
Okay,
message
okay.
me in the group. I will reply.
Okay, okay. Cool. Yeah. Yeah. Thank,
Okay. So any
thank you.
other questions? Okay. Okay. So we'll continue tomorrow.
Okay, sir. Thank you.